Alrighty, so first things first, I took my anemometer and measured the wind speed entering the fan. I did this by taking 5 measurements around the outer third of the fan, 5 measurements around the middle third of the fan, and 5 measurements of the inner third of the fan. I then summed them up, calculated the average, calculated the average of each of the locations' velocity, added them all up, divided by 3 to get the total average velocity of the wind speed entering the fan. And I got that to be 4.22 meters per second. I then repeated those same steps for the wind speed exiting the fan, which you can see here. I got the average velocity to be 4.64 meters per second, and repeated those same steps for the wind speed exiting the tunnel, which I got a total average velocity of 2.33 meters per second exiting the cardboard tunnel. I then took measurements of the entrance and exit of the fan. Along with the exit of the cardboard. The area of the fan's exit and entrance are the same, which is 0.183 meters squared. But the cardboard exit is slightly wider, measuring an area of 0.204 meters cubed, or meters squared. After gaining this data, I then calculated the volumetric airflow using the area times velocity formula. For the fan inlet, it ended up being 0.77226 meters cubed per second. The fan outlet was 0.84912 meters cubed per second, and the tunnel exit was 0.65953 meters cubed per second. After I calculated all of these, I used the mass flow rate equation using density times volumetric airflow. The air density in Salt Lake is 1.225 kilograms per meter cubed. So using that, I got my mass flow into the fan is 0.94602 kilograms per second. My mass flow out of the fan is 1.04017 kilograms per second. And my mass flow out of the tunnel is 0.80742 kilograms per second. And then to calculate the volume lost, or the mass lost per second, I took the mass flow out of the fan and subtracted it from the mass flow out of the tunnel to get a mass loss per second of 0.23275 kilograms per second. Then I rearranged the mass flow rate formula to solve for flow rate, or to solve for the volume loss per second. So I plugged in the mass loss per second over the density of the air, which gave my volume loss per second of 0.189 meters cubed per second. I also had a discussion with my group where we talked about how to calculate the mass flow rate, the volumetric airflow, and we talked about some of the problems we encounter, like not having steady measurements with the anemometer, troubles with exact measurements of the entrance and exit dimensions, kind of discussing back and forth whether we should measure that from the outside of the fan blades, the outside of the actual fan. And yeah, we just kind of went from there. We continued our discussion with tunnel vision about air leaks and flow loss, because we all recognized that the flow was less coming out of the wind tunnel than coming out of the fan. And we discussed different ways that we could possibly reduce the amount of air leaks and flow loss by adding more tape to cover maybe some of the air pockets that are letting the air escape. We also talked about having a more precise cardboard layout by maybe bending a little bit of the cardboard and lining it up more perfectly. But besides that, that's what I have so far. Thank you.